Hello, today we're going to learn what is a function notation and how to apply it, and when to apply it. Function notation. Function notation is represented like this. F of x, g of x, or h of x. These three ways are just the same, and the three ways represent y. As you can see on here, we have with the f, with the g, and the h. And these ways, they're just representing a letter y. So in a linear equation, when you have it just like this, f of x equals 2x plus 3 is just the same that if you have y equals 2x plus 3. So I'm going to tell you the names of each of the parts of a function notation. F. F is the name of the function. F of x. This is the way you read it. You don't read it fx. You read it f of x. Because it's the function of x. X is the input that is related to the domain. And 2x plus 3 is our output that is related to our range. This range, as you can remember, is always related to the y. So that's why we call the output also a range. So let's look on this example. We have y equals 4x minus 2, but we also have f of x equals 4x minus 2. And f of x equals 4x minus 2 is just the same as I told you before as if you have the y. Because on here, what you change is the y. Now, let's see on here. If they tell you, find the value of fx if x equals 2. What do you need to do when they tell you if x equals 2? When they tell you if x equals 2, what you need to do is replace the values you have of x. So instead of placing f of x equals 4 times x minus 2, you will place it like this. F of 2 equals 4 times 2 minus 2. You solve it normally. 4 times 2 equals 8 minus 2. And 8 minus 2 is 6. So on here, you don't need to move this 2 because the 2 is not multiplying the f. They're just telling you that is f of 2 when you work in the function of x equals 2. So our final answer in here, when they ask you if x equals 2, using this function is f of 2 equals 6. Now let's see another example. When they tell you if fx equals 2, as you can see, something a little bit different. Why? Because in here they just ask you when x equals 2. But in here it's different because they tell you when fx equals 2. So you will replace in here the value of fx and not just the value of x. You will not touch the x because what you need to find in here is which is the value of x when fx equals 2. So I'm going to substitute on here. Instead of placing f of x, I'm going to place 2. 2 equals 4x minus 2. I leave my variable completely alone, moving this negative to the other side positive, and I have 2 plus 2 equals 4x. I add the same numbers and I have 4 equals 4x. I move this 4 that is multiplying the x to the other side, doing the opposite operation, that is dividing. And I have 4 over 4 equals x. If I simplify this, I can know that my answer will be 1. So x equals 1 when fx equals 2. If I work with fx equals 2 in this function, I know that my answer will be 1 for x. Okay, now let's do another example, but they're a little bit different. I'm going to use this equation, f of x equals negative 5x plus 1. Okay, I have 5x plus 1. And I need to change what they tell me. When f of 4. Work when f of 4. So what I need to change in here, I don't need to change all the f4. I just need to change the value I have in the x. That's the reason why I need to change and substitute the values of all the x I have in here by a 4. And I have f of 4 equals 5 times 4 plus 1. I multiply my 5 with the 4 and I add the number 1. Then I'll have f of 4 equals 21. Knowing this, I will look that this is my final answer. F of 4 equals 21. Now let's do another example. And here the instruction is a little bit different. They tell us, find the value of x. What you need to find is x when fx equals 7. So what you need to substitute is all fx. So let's do it. Let's substitute this fx and don't touch anything else because you need to find the value of x. I'll have 7 equals 5x plus 1. I move my 1 to the other side. If on here is adding, on the other side will go subtracting. And I have 7 minus 1 equals 6 equals 5x. I need to move this 5 to the other side. And if on this side is multiplying, on the other side will go dividing. So I move my 5 to the other side dividing, and I have 6 over 5. As you can see, on here we have an improper fraction. So I need to make it a mixed number. And my answer will be 1/1/5 equals x. Okay, let's do our last exercises. Now we have g of x. We're not working anymore with f of x, but remember this doesn't change anything, just what you can see, but anything else. Find the value of g of x when x equals 2. Okay, as you can remember in the other one we changed gx, but on this one we're going to change the x. So I'm going to substitute each of the values of x I have on the equation. Instead of placing g of x equals 9x plus 3, I'm going to place g of 2 equals 9 times 2 plus 3. This way I have to multiply my 9 with the 2, and I will have g of x equals 18 plus 3. When I add this 2, my answer will be g of 2 equals 21. And there is my final answer. Now let's do our last example. gx equals 9. When gx equals 9. Okay, what we need to change in here? The g of x. So instead of placing the g of x equals 9x plus 3, I'm going to place 9 equals 9x plus 3. Now, I need to leave my x completely alone to find which is the value of x. So I'm going to move my 3 to the other side, and I'm going to have 9 minus 3 equals 9x. I subtract these two values, and I have 6 equals 9x. My 9 is multiplying the x, so my opposite operation is dividing. I'm going to move my 9 to the other side, dividing. 6 over 9 equals x. On this fraction, I can simplify it. So I need to simplify it to the lowest term I can. If I divide both by 3, I'll have 6 divided by 3 equals 2, and 9 divided by 3 equals 3. This way, my answer will be 2/3 equals x. And this will be my final answer. So, if you have any doubt of this, how to get the function notations, you can leave it in the comments below. And thanks for watching.